All right, welcome to this month's Art Club Safety Training Series. This month's on electrical safety. Again, I'm John Kenny from Cottney Consulting Group, and I'm always happy to be here and look forward to another learning lesson on electrical safety in our industry. Be safe. Burns, electrocution, shock, arc flash, arc blast, fire, and explosions. These are some of the items we're going to cover in today's presentation. So electrical hazards, burns, most common shock-related injury. There are three types of electrical burns. There's a typical electrical, there's an arc flash, and a thermal contact. So electrical is what you would think it is, electrical shock. Arc flash, we don't take enough caution in our industry with that. Electricity can flash as much as 20 to 30 feet from the original source in high tension. Thermal contact, you may not look like an electrical issue, but you can actually get a burn from a contact with something that is electrical shock. Electrocution, well, number one, it's fatal, meaning to kill with electrical shock. This is a number one reason that we want to be safe and be safe around electricity is avoiding electrocution. Results when the human is exposed to a lethal amount of electrical shock. Shock, the body becomes part of the electrical circuit. Reflex response to passage of electricity through the current of the body. If you've ever, I'm sure on TV, you've probably seen this when they reenact it on different TV shows, your body actually becomes part of the circuit. You cannot move and your body starts to shake. This could lead to electrocution or can stop your heart or other damage within. Arc flash blasts, an arc blast. The arc flash, sudden release of electrical energy through the air when a high voltage gap exists and there's a breakdown between conductors. Gives off thermal radiation, heat, and a bright, intense light that can cause burns. Temperatures can be as high as 35,000 degrees Fahrenheit. A great example of an arc flash is lightning. That's what lightning is. It's a flash, arc flash coming down through the sky, contact with the ground up, and you now have a big flash and you've got a high temperature. The arc blast is high voltage arcs that can produce considerable pressure waves by rapidly heating the air and creating a blast. This becomes particularly dangerous when we're working around high tension wires or we're working around transformers and such. I've seen them blow through the years when we've worked on roofs, and they are very, very dangerous. So these are things you need to consider and understand. Fire. Most result from problems with fixed wiring. Problems with cords, plugs, receptacles, and switches also causes electrical fires. So what we mean by there, you can have a fire within a wall from a permanent wire, or where we can run into problems is we can have fires that start with our extension cords, plugs, receptacles we're plugged into, and other switches on equipment and will cause electrical fires. So electrical fires can happen. Explosions. They occur when electricity ignites explosive mixture and material in the air. Note, electricity is a source of these hazards. All hazards are of equal importance. Lessons focuses on eliminating electrical hazards. You want to focus when you're teaching your people about these on avoiding these electrical hazards. Like we talked about in our prior presentation about static electricity. Static electricity can ignite adhesive. Same way a short or some kind of electrical short out or explosion or whatever it may be that we just learned about prior can also cause ignition of flammable liquids on our projects. Power lines. Contact with overhead power lines. Overhead and buried power lines carry extremely high voltage. So we not only worry about overhead, we have to worry about what's buried in the ground when we're going into our job sites. The risks. Risks are electrocution is the main risk. Burns and falls. You can get shocked or an arc from one of these and fall off a ladder going up. Cranes are not the only equipment that can reach overhead power lines. Use of ladders or suspension in manned baskets under near power lines are at risk. The covering of overhead power lines is primarily for weather protection. Therefore, workers need to know that if they touch a power line, covered or bare, death is probable. So because it looks insulated does not mean it's going to protect from electrocution or electrical shock or burns. And again, I want to go back to what we just talked about earlier. These things under the right conditions can arc 20 plus feet. So we have to take very cautious of what we're working around. Real life examples. So here's a case one example that I came across. A worker is electrocuted when the ladder came in contact overhead power lines. Happens more than you would think. Lifting a ladder up, carrying it on top of the shoulder, different ways it happened, raising it up onto a building. The power line is closer than we think, or it arcs. Case two, worker electrocuted when the mast come in contact with high voltage overhead lines. Crane, you're not grounded and protected on the crane, you can still get shocked or electrocuted. Or when you go to jump off, if you not realize that you have created a power connection, you then will be electrocuted. Or anyone working around you up to 10, 15, 20 feet or plus, if this happens, can also be electrocuted. So what does that mean? If it's up near the roof level, you could electrocute your entire crew if this situation happens. So again, we must be mindful. Severity and effects. So severity and effects of an electrical shock depends on a different but matter of factors, right? Pathway through the body, where the current travels, the amount of the current, length and time of the exposure, whether the skin is wet or dry. Remember, moisture conducts electricity. Water, great conductors, allows current flow more easily in wet conditions than through wet skin. So, water is a great conductor of electricity. Also remember, working in very humid conditions, that is moisture. What will that do? That will increase the amount of conductivity of electricity when you come into contact. Types of electrical hazards. Capacity affected by size of wire, like 14 gauge is for 15 amp service, 12 gauge is 20 amp. Length of the cord, UL tag capacity. In general, any cord over 100 feet requires one size larger cord, 14 gauge to 12 gauge. So when we're putting that, so what does that mean in real life example? You're not going to be able to put two 14 gauge 100-foot cords together, okay? It's going to create a problem, can possibly create a shortage and overload and many other issues. So you would then go to the next gauge lower of 12 gauge and so on and so forth, which is why we do not recommend adding a bunch of cords together and keeping the source, like your portable generator, within the range to make things easier and safer. Types of electrical hazards. Damaged or bare wires. Fault current may travel through the body, causing electrical burns or death if a power supply is not grounded, path has been broken, or there are live parts or bare wires. So, extreme conditions and rough treatment can change electrical equipment from safe to hazardous. What does that mean? Inspect your equipment daily. I always like to have my equipment inspected in the morning and again in the afternoon to make sure nothing has changed. What can change? Pulling and tugging on a cord, having something change in the with the conditions, water, laying through a puddle. A lot of things can happen, so always be aware. Defective equipment or tools. So, one thing we got to remember is improper repairs. Example of incidents. Ballast strap not replaced after repair, electrocution 11-old boy, right? These are examples of what we've heard out there. Cutting off bleed resistor and capacitor causes a 370-volt shock. Removing or leaving a thermal insulator on capacitor causes a 440-volt shock. These are all from OSHA instances that happen on job sites. Now, that doesn't mean that you're going to have this affect you up on the roof, but the same thing has to be taken in context with the different type of equipment you use. And also, if you do plug into building power, you need to be aware of what you're plugging into. Power strips. This is an example of a home power strip we're also used to, but also we're learning a lot here about safety and in the field. There's also safety to consider inside our buildings and offices and warehouses, not to overload because of multi-plug arrangements. So a power strip, which is a ground fault receptor we use out on a roof, we don't want to overload. And we also want to take caution to the ones we're using with inside our operations as well. So again, use fixed wiring whenever possible. Smaller extension cord, shorter whenever possible. But when you start to run off of multiple things, make sure that your ground fault receptor or your power cord that you're plugging into is of a higher gauge than what you're running off of it. Because again, you don't want to cause an overload. Short creates fire or electrocution. So here's some stats in the United States. An average in construction, electrocution deaths account for 9% of the total fatal injuries in construction. So that's basically one in every 10 fatal accidents are due to electrocution. Nearly 60% of electrocutions were caused by direct contact with electricity, when the other 40% is your arcing. Electrocution is sixth among causes of workplace and deaths in America overall. So this is not something to take lightly. This is as important as everything else we've been learning in these monthly videos. Electrical protection methods. So voltage up to 50, minimum clearance is 10 feet. 50 to 200 is 15 feet. 200 to 350 is 20 feet. So on and so forth. And you can see you got a high voltage power line, 750 to 1,000, you're 45 feet of clearance. Over 1,000, you're probably going to have to contact, that's a transmission station, you probably need to contact for safe distances right from the power company. You should always verify with them anyways what you're working around. But this gives you an example of how dangerous electricity can be that we work around and how far it can travel. So below 1 milliamp, generally not perceptible, which means you're not even going to feel it. Milliamp is a faint tingle. 5 milliamps is a slight shock, not painful, but disturbing. 6 to 25 milliamperes in women is a painful shock, loss of muscle control. 9 to 30 in men is a freezing current to let go range. Individual cannot let go. Now, I know you've seen that in TV shows that I've watched, and I'm sure you've watched them where you are frozen. That's the way they show them. So that happens. Again, right on down to you finally see if it's a 10,000 milliamperes, cardiac arrest, severe burns, and deaths probable. So again, depending on what you have coming out, this example to give you above what we looked at, 1,000 milliamperes are 1 amp, therefore 15,000 milliamps are 15 amp circuit. So 15 amp is not that great of a circuit, and you've got 15,000 milliamperes, which we look down there, that puts us above the cardiac arrest, severe burns, or death probable. So again, it doesn't take high voltage in order to create these issues. So what's wrong with this picture? Well, we have one over here with tape around it on the right side of your screen, looking at it with tape over a damp floor, which is a what? Entangled up, and a trip hazard on top of that. So this has got multitude of problems. We look over here to our left side, we've got a cord that's been wrapped too tightly. It's all twisted up. We also, the most important thing is we're missing a ground. This is meant to be a 3-prong cord, and you can see the ground is missing. So again, we need to be aware and do our visual inspections. Electrical protection methods. Use power tools and equipment as designed. What does that mean? Don't use a power drill as a hammer, which I've seen on the roof. Follow tool safety tips to avoid misusing equipment. You need to have an onboarding of the different types of equipment you're using in electrical equipment and what are the safety tips and measures to use when you're training your people. Always follow manufacturer's instructions. If it tells you it's only to operate in certain conditions, then those are the conditions you must operate in. Electrical protection methods. Use ground fault circuit interrupters, GFCIs, always. This has to be a must in our roofing world or any construction world for that matter. You have to use these. They're required. You've seen these in your bathrooms because of water shock, but on a construction, you have to use them so that if something shorts out, it's shutting the power off. What are they used for? To design and protect people from electrical shock. Detects ground faults or interrupts in electrical circuit or surges. Limits the length of electrical shock. So you can get zapped, but it's quick and it turns off. So again, this is an OSHA violation if you don't use it, but also common sense. We want everyone to go home safe. Electrical protection methods. Common examples of misused equipment. Again, ground missing up there. I've seen it all the time. Done. Down here, a nail through an extension cord. Kind of reminds you of the Christmas light deal. And again, what do we see that's wrong in the other picture? Open wiring that's taped together. I cannot tell you how many emergency repairs I've done out on a roof. I've seen out on a roof site done that look like this. Extremely dangerous. If you have something that needs to be taken out of service, you cut the ends off of it and get it off the roof as soon as possible. So electrical protection methods. So we have tool safety tips. Never carry a tool by the cord. We've seen that. Never yank the cord to disconnect it. You do that at home too sometimes. Keep cords away from heat, oil, and sharp edges. Heat, oil will absolutely destroy the insulation value, and sharp edges can cut through. Disconnect when not in use and changing accessories. Do not hold fingers on the switch button. So do not hold your finger on the equipment when you're trying to unplug it. Use gloves or appropriate footwear when you're operating equipment. Store in dry place when not using. Moisture can get into these and cause electrical shock if they're not kept dry. Don't use a wet, damp environment. So again, roofing is a wet, damp environment, but you have to use the proper caution and not drag cords across water, and do not lay your electrical tools in damp or wet areas. Keep working areas well lit. Especially happens working at night, and especially the hotter it gets out there working in the roofing industry we have at night. So make sure everything you're using is enough light to see it in if you're working off hours. Ensure that cords do not cause a tripping hazard. So we've talked about all the other electrical safety things we need to talk about, but how about those cords running all across the roof and people end up tripping over them? You got to make sure that your pathways are clear where these are being used and people are aware they're there and they don't trip and fall. Remove damaged tools from use. I cannot stress this enough. Once it's been damaged, get it off your job. Best to always cut the end off of it so no one else can reuse it. I know that sounds like I don't want to ruin it. I can fix it. Don't be that way. Extension cords, power tools, whatever it is, cut the ends off, get it off the roof, put it in the back of your truck. If OSHA comes out and you have a damaged tool in the back of your truck, you will be fined unless that end is cut off and it's marked out of service. Use double insulated tools. Most of the tools that we buy are double insulated, but take caution. There are knockoffs out there that are not. Be aware and know what you're purchasing. Electrical protection methods. So again, follow lockout tagout procedures. Lockout tagout, essential safety procedure, protects workers from injury while working on or near electrical circuits and equipment. Prevents contacts while operating equipment such as blades, gears, shafts, etc. Happens. There's a unit on the roof. There's equipment on the roof. There's power that's been shut down. If you're the one shutting it down, make sure you follow these protections so someone can't turn it back on and causes danger. So again, you'll use this method when you're repairing tools that's not plugged in. We don't use this as much as an electrical contractor would, but you need to be aware of them and make sure in our world we're following what needs to be followed. Lockout tagout prevents the unexpected release of hazardous gases, fluid, and solid matter in areas workers are present. So there's a lot of different ways this can be used. Employer requirements. So as an employer, your requirements are to protect your workers. You must ensure overhead power line safety. You must isolate electrical parts. Supply ground fault circuit interrupters. That is an employer's responsibility. Establish and implement an AEGCP, which is your plan, right? Ensure power tools are maintained in safe condition. So it's not only your responsibility to purchase them most of the time as an employer, you have to make sure that they are safe. So what if your employees have some of their own power equipment? Can happen, drill guns and so forth. It is then still your responsibility to make sure they're in a safe operating condition. Ensure proper guarding. Guards are put on these power tools for a reason. Provide training. Again, make one of your onboarding and your safety practices be training on power tools. Enforce your lockouts, tag out safety related work practices if they're pertainable to what you're doing. Ensure proper use of flexible cords and power strips. Ensure proper identification of power sources. So these are a good guideline, a few things we remember, and then we will be good. So what are some key takeaways of electrical safety? Understanding what electrical hazards are to begin with. So you want to work with your team on common hazards, which include burns, electrocution, shock, flash, blast, fire, and explosions. Awareness of these hazards are critical to preventing serious injuries and fatalities, and they are your responsibility under OSHA training guidelines. Electrocution risk. Electrocution is fatal and occurs when the body is exposed to lethal amounts of electrical energy. One of the leading causes of death in the construction industry, like we said, 1 out of 10 fatalities are from electrocution. That's a lot. Electrical shock and its severity. We covered that. What happens if you got a wet or dry condition? Moisture attracts as a better conductor of electricity. You need to understand all those things and make sure we're working on the safe side. Arc flash and arc blast. We talked about that, how it can arc and how you can even have a blast from electrical being pushed out to you with a warm air and set something on fire. Proper equipment and grounding. You got to check them. You got to check them multiple times a day. Make sure we're operating and safe and the equipment is safe. Power line safety. You got to know what kind of power is running near and overhead. We have electrical services coming into buildings. Sometimes you will need to shut them off in order to work around them safely. Then you will have to build a barricade to make sure someone doesn't go back into that area while you're working on other areas of the roof after you've completed it when the power goes back on. Lockout tagout is a procedure you use on certain conditions, and you may never use that in roofing, but it's good to know what it is and how you would use it. Employer responsibilities. Like everything else we do in our industry, the employer is responsible for safety. So you want to make sure you have a plan in place. It's part of your safety training, part of your employee training, and you have everything supplied and in good working condition that's required. So that brings us to the end of this presentation. Again, I thank you all for listening. And if you have any questions, please reach out to our club or myself, John Kenny at Cottony Consulting Group. See you next month.